So we've done create, we've done read, and for the CRUD operations, that leaves us with update and destroy. So again, active record is just the abstraction that is making this connection for us. Once we finish these operations, we're going to see how the controller actually uses the active record calls to connect the views in the model. And kind of one really important example of that is how HTML forms work. And I'm going to plant this seed ahead of time so that you sort of have it in the back of your mind as we get to that part of the material. Remember that the sort of Rails view of the world is a model is a resource. And a resource just has these very basic operations you can do on it. And we're not thinking of our app as a collection of actions. We're thinking of it as a collection of resources. And at what point do you create or update a resource? What are the relationships among different kinds of resources? For that reason, when we talk about HTML forms, we're not going to be thinking of, here's some pieces of information we're going to collect from the user, and then we're going to do something. We're going to be thinking of the underlying object, right? Whatever resource in the app, that form is there to help us create or update. The form is really just a way of getting at the resource's attribute values. So everything about the way that forms are handled, both the way that you specify how to create a form in an HTML view, and when that form is submitted, the way that you handle receiving the form and doing something with the data, all of that is a sort of very resource-centric point of view. So think of a form as, this is a way to operate on a resource. And from that point of view, the way that forms are handled will make a lot more sense. So before we get to that point, we still have to cover updating and deleting. Updating is actually very similar to creating, because if we have created something using the syntax that we just showed, now we can go find it. And by the way, in this example, since I'm about to show you how to do an operation on a single movie, why do I have to call first on the result of where? It's because where returns a list of all the movies that could match. It returns a thing that quacks like an enumerable. Remember that where returns an enumerable collection of 0 or more things that matches. So, because I'm doing an example where I want to show you how you update a single one, I'm just going to say, grab the first one. And by the way, in real life, I would have to verify that there is a first one, right? Like the collection could be empty. And so when I say first, what I'll get back is nil because there's nothing in the collection. But in this case, we're going to assume that it works. And then again, just as with creating, there's kind of two ways to update the value of attributes in a model object. One of them is I can pull the model object into memory, like I did here by using where. And then I can use the setters to modify the attribute values one at a time. And when I'm done, I can say save, and that writes it back to the database. Or save bang, if I'm very brave and I want to make sure that writing it to the database, if it doesn't work, I want to have an exception and a loud explosion. Or similarly with create, there is another call that once I have a copy of the object in memory, I can just call update, and I can pass a hash of only those attributes that I want to modify. The other ones that are not mentioned in the hash just stay the way they are. You can either create something all at one time, or you can create a new blank object, fill in the fields, and then save it. Same thing with update. Once you have an in-memory copy of the object, you can either call update and do everything at once, or you can modify the values sort of one at a time, and when you're all ready and done, then you call save. Note, if you are reading code before version 6.0 of Rails, the update method of active record was named update attributes. So sometimes you will see update attributes if you're looking at an app that was built with an earlier version of Rails than Rails 6, but it does exactly the same thing. And we'll talk a lot more about database transactions, which are a wonderful, wonderful thing that saves us many headaches as SaaS developers. But suffice it to know that when you call update, either all succeeds or all fails. So you pass a list of attribute values that you want to modify, and either all of those values get updated or none of them get updated. It's an all or nothing transaction. And there are actually many other cases in Rails where we're doing that. We'll take advantage of that as well. Deleting, so this is the last of the CRUD operations, delete or destroy, is very straightforward. The only thing that might be a little bit counterintuitive about it is that it's an instance method. So rather than saying, hey, movie class, destroy the movie that matches the following criteria, you first grab a copy of that movie and then you say, you, destroy yourself. So I can look up a movie, and again, I'm going to use first to make sure that I actually just get one and not a collection. And then I can call destroy on that object. That actually removes the corresponding line from the database. And as we'll see, it actually does a bunch of other things too, or it potentially does a bunch of other things. At the risk of skipping ahead just a little bit, the sort of next big chunk of material after you are familiar with active record is how do you create relationships between models? For example, I could have a model representing a course, and a model representing a student, and I want to set up the relationship that a course can have many students in it. But that means that if I destroy an instance of a particular course, what's supposed to happen to the students who are associated with it? Should those students also be deleted? Should they just be unlinked from that course in some other way? And so when you set up relationships like that in Rails, destroy not only destroys the object that you're calling it on, you can also have it sort of take care of any of the associated dependencies, and you can sort of tell it what's the right thing to do with those dependencies. So destroy is simple, but it's not that simple. The other thing about destroy that's interesting is that once you have called destroy and successfully removed that row from the database, you can still look at the attributes of the object, because remember, you have a copy of it in memory, right? So again, this is the abstraction that's not completely watertight, because I read something from the database and I said, okay, destroy yourself. That causes the database copy to go away. But there's still this copy that's hanging around in memory. And you can still inspect the attributes. Basically, what were the attribute values when you just read it from the database? But if you try to modify those attribute values, you will get an exception. Because it sort of doesn't make sense for you to have just removed something from the database and then subsequently try to modify its attribute values. As a point of interest, how do you think this is implemented? Because, before I said, well, to update an active record model, you can load it from the database, and then you can call these setters, and you can set the attributes one at a time, and then write it back to the database. Now I'm telling you that if you have just destroyed that object, then actually trying to do this will throw an exception. How is this probably implemented? Part of it is the in-memory object has to have some indication that it's no longer alive, right? It's been destroyed. And so remember that, as we keep saying, this looks like I'm just setting a attribute to a value, but I'm not, right? Remember that I'm calling a method. That in Ruby, all of the variables, all access to instance variables is through getters and setters. And so here, title equals is actually a method that is defined by active record as a way to set the value of the underlying attribute. And that setter method can look at the value of the flag that says, oh, you can't modify, this object was already destroyed. And at that point, it can raise an exception. Since I like to introduce students to the history of our awesome field, to talk a little bit about Barbara Liskov. We're going to have a lot more interactions with Barbara Liskov's work when we talk about design patterns and refactoring. But she's actually a Turing Award winner who was a double major in math and physics at Cal. She was one of the first women actually ever to be awarded a computer science PhD from any institution. She got her PhD at Stanford. And she's won too many awards to mention, but the Turing Award really recognizes as her main contribution the invention of abstract data types. And this is I remember being in the audience when she was being introduced to sort of give her, award speech. And there were some undergraduates sitting next to me, and the person introducing her was explaining the idea of abstract data types and Liskov substitution, which we'll learn about later. And one of these students said, why is she getting an award for that? Everybody knows that. That's why she's getting the award. Basically, her discovery, and this is before the idea of complex data types with, different attributes and methods and that, getters and setters that can do whatever they want. She basically came up with the sort of foundational framework for that idea, that if you define an object that has a fixed set of behaviors and those objects' instance variables, its state, are hidden from the outside world. In other words, there's no direct access to the underlying attributes. You have to do everything through getters and setters that are explicitly defined. If you do that, you have basically defined a new data type, and you can define the behaviors of that data type and how it interacts with the rest of the world. And she invented a sort of research programming language called CLUE for clusters, because the idea is a cluster is the name that she gave to a collection of attributes and the behaviors that encapsulate those attributes and hide them from the outside world. And so your program would be defined as different kinds of clusters and how the clusters interact with each other. So she essentially invented what we now think of as the idea of abstract data types. And in fact, Ruby's model of information hiding, where you can't get access to instance variables directly, you have to do everything through getter and setter methods, that really is kind of a direct descendant of her work. So it's fun to find opportunities to sort of tie, the highest award you can win in computer science is the Turing Award, and to see how pervasive those ideas are and how they really continue to inform the design of modern programming languages. So that's my little history tidbit for the day.